You guys want to go back and watch it, or I know sometimes we can't finish in time, and then if you have English, I'm not sure if you guys have English. Okay, you guys will be right there, so like the donuts and stuff. Alright. So, not anything too different than Sean, last time, or you have to leave. Okay. Not too much different than the first chapter, except now we have inequalities. Okay, so we've been talking a little about inequalities the last few weeks. We'll go through as much of the review. I'll try to do like all of the version 1A or the 2A and so forth, and let you guys do the B problems. Just like last time, this review is going to be twice as long as the actual test. Okay. So, the first type of problem, we want to write the sentence as an inequality. What are the 4 types of inequality signs that we're primarily working with in this chapter? Greater than, so greater than opens to the left, right? Less than opens the other way. Okay, and I need 2 more. They're very similar, right? Greater than or equal to, and then less than or equal to. Okay. The big difference. So if you're comparing 2 different numbers or 2 different values, and I don't know why sometimes when you start it like flashes for a while. So hopefully you're going a seizure or something from that. But so you have 2 different values. One will be smaller than the other, okay? The difference between the or equal to part means that they can actually be equal to each other, okay? So let's look at the first one. A number W plus 5, so this is going to be probably the one side, is at least, this is another part, at least 19. So I have my 3 parts. Now if you think about our inequality as like the left side, the sign, and the right side, then there's 3 parts. How would I represent W plus 5?
So for
it's almost as easy as like when you read it, when you write it down, you would say the same thing. Where it may get a little bit trickier is like if they say the sum, then you have to know that sum is another word for addition. So you would put a plus sign. Or if they say the difference, what is difference? Subtraction. Product is multiplication. Quotient is division. Things like that. Okay. We'll come back to the sign. I have 19, so I'm going to put the 19 over here. Now, if W plus 5 is at least 19, so some of these you have to stop for a minute and like really think about it, and you can even try out some numbers to see if it's true or not, because W plus 5 is at least 19. You guys think that the W plus 5 is bigger, or it can be bigger, or do you guys think that 19 would be bigger? The W plus 5 would be bigger, yeah. How did you, what helps you realize that? Or is there something that you're thinking about that helps, that maybe we can follow with?
because it's at least 19, it could be equal to 19, but it's at least 19, so it's bigger.
Yeah. If your friend said, oh, we're gonna go, I don't know, we're gonna go to the movies, bring at least $10 for tickets, because they usually are the lowest is like $10 or whatever it is. If you come in with like $8, then you didn't bring enough money. You're not going to be able to go to the movies, or unless your friend's nice and they'll give you a few dollars. Okay. So yeah, W plus 5, it's bigger than, and then the at least means it could be 19. Okay. What about the temperature T is no greater than 55? So this one is actually 3 parts as well. What are the 3 parts? T is one of them. Good. Alright. Give me another part. Okay. Greater. I want to put no greater than. Okay. And then there's only one part left. What do you two want to tell me? 55. Yeah, it's 55. Okay. Alright, so let me write these real quick. I know the T over here on the left. I'll put the 55 first because sometimes the actual sign, making sure that it goes one way or the other is the toughest part. And then putting the line or not putting the line is like the next maybe toughest part. So T is no greater than 55 degrees. So if I say something's no greater than, if the temperature is no greater than 55, if you're having trouble thinking about, oh, which way does it open, just try a couple numbers. Try like 60, or even if I try 56 or 54. Okay, if which one is no greater than 55? Yeah, the 54. Okay, so then the 54 needs to be smaller than the 55. Okay, that helps me decide that the sign should open up towards the bigger thing, which is 55. Alright, can it be equal to 55? Then sometimes this one's tough. This one can be, okay? No greater than means it could be 55, but once you get to like 55.1, then it's too much. But no greater than means 55 is okay. Okay. And then our last one. So your card C, that's one part, can be no more than 15,000. Okay, so right now, let's put this in the market for a vehicle. So go to some different places. No, I can see it like blinking on your face. Right. Okay, go ahead and try it out real quick, guys. So if you haven't already, give it a try. If you get it wrong, we're gonna fix it in a minute, so we'll be able to, change it before you turn it in. Okay, and if we do some of these problems and you feel really good about something like number 3, you know how to do, and you can skip on to like the second parts while you're waiting for the rest of us to catch up, that's totally okay too. Let's check it out. So my part is C, 15,000. Does anybody have a car or driving already? Are you guys driving? So you're hoping to drive soon? Okay. I didn't end up driving until I was a senior. So I waited until you didn't have to do like, you get your permit at like 17 and a half, and then you don't have to do like, is it called driver's ed or? Yeah, whatever, yeah. So, but then I had to wait till I was 18 to actually have my license. Lucky me, my birthday was like at the end of my senior year, so that kind of stunk. I couldn't really drive until the last few weeks of school. But sometimes, I mean, maybe you take out a loan, or maybe your parents will tell you have a budget for money, or you get a job, and you kind of pay for your own car, kind of like the route that I took, but you have like a certain amount of money that you can or can't spend. So in this case, let's say you had a pretty good budget for maybe your first car. I think my first car was like $5,000, so that was about 3 times as much. But it says the cost of the car that you maybe want to buy can be no more than 15,000. What's an amount that you know you couldn't buy? Maybe you went to the actual like car lot and they had the price sticker, Or maybe you're looking on like online for someone that's selling their car, and they say what the price. What's a like amount for sure you know you could not buy based on this? 1600 you could. 16,000 you cannot, right? Yeah. So like if you see it online, it's like 20,000. Notice no negotiation. Then you know you can't buy. What's something you could for sure buy? Maybe 2,000, or 3,000, or 4,000, 5,000. Grow up. What's the most that you could pay for a car? 15,000. How do I know it could be 15,000? Because it could, like sometimes it has to be strictly smaller than, but in this case it can be 15,000. When it says no more than, they're not being like super specific. Okay. So which way will I open my sign? To the left or to the right? Okay. If I open it this way, okay. If I open it this way, now it's saying the cost could be, what's a number, like this sign says that this number here has to be bigger than the one on the right. So a number like 20,000 would be bigger. But I kind of know, then I have to look back at my problem and say, it can't, I know that it can't be 20,000, right? It has to be smaller than. So a number that would work that we said is maybe, well, I don't know if we did say it, but maybe 10,000 would work. But I know that 15,000 is a bigger number. Right, so I actually want to change that sign. Okay? And then I can do 15,000. Got it? Alright. So try 1B on your own. Let's check out 2A and 2AB. Real quick, give it like 30 seconds for each if you haven't already. Try to write the inequality. Okay? My clue for you is that if there's only one like circle or one dot, there should be only one number that you care about. Okay? If they don't give you a variable, you can pick which variable you want. A lot of times we pick x. It doesn't have to be x. And then also we talked about using the inequality sign to point to which way you shade. Okay, so that's a tip too. Alright? And then also the open and closed circle part changes up your inequality. Okay, so we're only going to do the first two, but if you want to go ahead and tackle the last two, go ahead. Hopefully when you see these problems, they're not going to take you too long. Alright, let's look at the first one. Let's see, which number do you think I care about? 6, yeah. Alright, and then remember which side do we like the variable? Because I could write it over here, or I could decide to write it on this side. Which side do we prefer? The left side. The left side's nice because it helps us in our shading. Which way am I going to point? To the right. Okay? Now the tip is that, I'm looking at this as it's pointing this way, going to the right. Okay? I can't use that rule if my variable's actually on the other side. Okay? Alright. Do I use the line underneath or not? Why not? It's an open circle. So remember, open circle means there's a circle. Open means I'm not shading it in like that. Okay, so a closed circle would mean actually fill it in. Alright. Arlette, what number do I care about here? 1. Alright. Is this going to have a line or not a line? It will have a line. Okay, and which way am I pointing? To the right. So this is actually a what kind of inequality sign? A blank or blank. It's actually a greater than or equal to part is correct. Okay. So the difference between knowing if it's greater than or less than, you're just looking at the left side and the right side. Which one's opened up bigger? So the left side here is opened up bigger, so you're going to say greater Alright. You guys feel okay about those? Alright, let's check out number 3. We've got a bunch of inequalities to solve. You guys want a couple minutes to try a few of them, or do you want to just do it? Try it. Okay, go ahead and try them. I'll give you guys just a couple minutes to just do a few of them. If you can't, just skip to the ones that you feel like you can do, and if there's one that looks like too tough, just move on to a different one. We'll come to all. Remember, when you're solving an inequality, it's just like solving an equation. What's the only difference? Pardon? Yeah, you don't have an equal sign, and when is it? Remember, we have to be careful because sometimes the sign changes direction. When does it change direction? I think we talked about this last week, maybe also the week before. Right? Remember? Okay. When do we change the sign? When do we change the direction of the sign? So like right now, it is opening to the right. What would be the only reason why I need to open it to the left? If you multiply or divide by a what? A negative number. So if you multiply by a negative number, on both sides I should say, because if you're distributing only on the one side, that's separate. But if you multiply both sides by a negative number or divide both sides by a negative number, then you have to change the direction. Everything else, you leave it alone. The only other reason why you would flip the sign is if you want the x or the y or whatever on the left side, and you just flip the whole inequality. Okay? Alright, let's look at 3a. I want what by itself? Z. Okay? I do have a z by itself on the left, but really there's a 6z on the right, so I've got to move that over to the left. Okay? I am just going to subtract 6z from both sides. Okay? And then that cancels out, right? On the left, I've got z minus 6z. What is that going to be? Not 6. I will be something negative, though. Okay, so let's do some review. I think we talked a little bit about this in the beginning of class last week. When you're adding or subtracting, okay, could look at the signs. So remember, this is technically a negative sign, and this would be a positive sign. They're different signs. I can subtract these numbers, okay, ignoring the sign for now. So I'm going to say, okay, 6 minus, what would the number be for just the z on the top?
1.
Just 1. Okay? 6 minus 1. I know you guys can do that. Okay, so it's going to be 5. The only other thing that I need to know is, okay, am I going to use the positive sign now or the negative sign? And I'm going to choose the negative because the negative 6 is bigger than just the positive 1. Okay? So if we have to review some of that, or you guys want to review some of that outside of class, we can. Alright? And then I have, do I need to change the direction of the sign? No, because I'm not dividing or multiplying by a negative number, so this is still less than or equal to, and then 15. Okay? We used to have one called mirror, and it was the whole screen. And then we switched to this one. Now it's only like, that's as big as I can get the screen. And then lately it's been doing this like flashing thing. So that's like a help. divide by, and just to save us some time, don't say divide by 5. We want to divide by negative 5, okay? Alright, that will cancel out this stuff over here, right? And then I get just z on the left, 15 divided by negative 5. Well, first of all, is that going to be positive or negative? It will be negative. Alright? I think we talked about that last week as well, little ways to remember when you're multiplying and dividing positives or negatives. One of them was the triangle. Okay, maybe you guys have seen that already before. Another one was we talked about same signs are positive, different signs, so positive, negative, negative, positive. And then we might have talked about, I think it's still on the board from a different thing. A good thing happens to a good person, a positive, and so on. Okay. So this will be negative. 15 divided by 5 is 5. Why do I have to flip this side? I divided by a negative number. Okay, so that's my answer. Just for, not that they asked for it here, but it can't hurt to practice this real quick. I'm going to plot this on a number line. The one number that I care about is negative 5. Put a circle. This one I know is going to be closed because it's the or equal to. And my variable is on the left. It is on the left, so I know that I can just shade to the right because my inequality is pointing to the right. Yeah. Sure. Okay. We'll do this. We'll do B next. What else? These are due by 2 p.m. Thursdays. Okay. Okay. Do you guys not like this problem? Does it look easy? What's the thing that maybe you don't like about this problem? The fraction. So let me show you guys a tip to get rid of fractions. Okay? If we were solving a problem, so say it was like x over 3 equals 8. We would want to get rid of the fraction. How would we get rid of that fraction? Multiply, yes, by 3. Now I cannot just multiply the left side. I would have to multiply the right side. Okay? Maybe in the process, I make everything else a little bit bigger. Like I made the 8 now a 24, but I don't have any more fractions, and I would rather have that instead. Okay? Now I want to do something similar. But I have to be a little bit more careful because there's more than just one thing or just two things. Okay, so very quickly, I mean, if I wanted to, I could move the 9, or I could just say, let's just get rid of this fraction right away. There's only one fraction, so there's only one denominator. It also has a 3 in the denominator, so I would want to multiply this by 3. Right? If I do, then I'm going to cancel out the fraction on the left. But I can't just multiply one thing. I have to multiply everything on the right. And then also, I have to just actually even multiply the whole left side and the whole right side by 3. Okay? I know that when I multiply, I'm going to distribute actually this. I would have to distribute this, so it would be like a 3 times x over 3 minus 3 times 9. Okay? And then I would have a greater than sign. And then I would be distributing this 3 to the x and this 3 to the 2, so that would be 3 times x and 3 times 2. Some of this you probably could just do, instead of saying 3 times 2, you might just put 6. But I'll just put it a few extra steps in just for the practice problem here. What is this going to equal, guys? 3 times x over 13. Just x, right? Because these cancel. Okay? What about negative 3 times positive 9? Well, first of all, I know it will be negative, because one's negative, one's positive. They're different. What is 3 times 9? You use one of your fingers if you really have to. Right? 27.
I had a question
Yeah.
about why we subtracted negative 3 to
That's, I could let me rewrite, let's rewrite this then. This is a plus 3 times negative 9. Would that clear it up a little bit? Yeah, I should have done that instead. I think in my head I was thinking it's already going to be negative, so I put the negative out in the front. Sorry about that. Okay, and then greater than. Now I didn't write like 3 times x like that right there. I just said it's 3x because that's the same exact thing. And then 3 plus 2, they're both positive, they're both the same sign, so I know it will be a positive. And then 3 times 2 I know is 6. Okay? Now if I gave you this problem, if I gave you this, or this, I'm pretty sure you would tell me you'd rather do the second one, even though it's the same exact problem. Okay? We got rid of the fractions for like this part. We may end up getting a fraction as our answer since we already have fractions, but that's okay. Now going back here, what would I do? We have a couple options. What would you do first, Brianna? Combine the x's. To the left or to the right? To the left. Okay, so if you say to the left, then I'm assuming that you would subtract 3x from each side. Okay? These disappear. What is x minus 3x? Negative 2x. So some of you guys, I mean, hopefully a lot of us, that's easy. Okay, the other thing though, just to review what we talked about last week, that x is a positive 1x. The negative 3 is negative, so I could set it up as a subtraction problem. Subtract the 3 minus 1 to get 2, and know that it has to be negative because the 3 was the bigger one. Okay, so you guys need to do those steps to figure out which way to go. What would you do next, Alexia?
I will add 27
Yes.
to both sides.
Add 27. Negative 2x greater than 6 plus 27. What does that mean? 30. Not quite. Very close. You're getting further away. 33, yes. There we go. I think everyone will think about it a little differently, but for me, when I'm thinking about 6 and 27, I'm adding them together, I would think of like that 6 and add 3 first. You guys think about it like that? Or no? I'm thinking about like when I'm going to go 27 and add 6. 6 is the same thing as 3 plus 3, isn't it? So a lot of times, maybe not if the number's a little bit smaller, you just have some of these memorized. But I think 27 plus 3, I know that would be 30. And then if I add 3 more, then it's a 30. Okay. So you guys can do that for like bigger numbers too, but you can do it even for small numbers. Get rid of this. All right. Last step. Here's my math. Jaden, was that you or Alex? What's the other problem? Something about negative 2, yes, what about divide? What's the important step here, Jaden? You have to flip the sign because we just divided by a negative number. So I need to change the direction of the inequality sign. It was opening to the right / pointing to the left. Now it's going to do the opposites. And then negative 33 over 2, if you want to punch that into your calculator, you can. Or really all I care about that it's a simplified fraction. You can leave it like that. Alright, now while you finish copying up, copy. Not asking for it on this problem, but I could graph this, okay? The one number I care about is negative 33 over 2. I would have an open circle, and this open circle is going to shade to the left. Alright, let's check out C. Let's check out C. This is my first step. First step. Yeah, distribute. Distribute a, and then some of you guys don't need this, but sometimes I know for some students it's helpful to think about this as a -1. Okay, so I want to distribute the -1 to the 5, and also to the -13r. Okay. Enjoying this or no?
No, I've worked.
Okay. Yep. Okay. -12r stays the same for now. I have a -1 times a +5, a -1 times a -13r, greater than or equal to 9. You may just like already do -1 times 5 and put -5, or -1 times -13r and then put a +13r. But if you want this extra step, you can use it. I'll just put it that way. Hopefully I don't lose you on the steps here. Even though I'm multiplying by a negative number, I'm multiplying kind of by -1. I'm only doing it to one side. I'm not going to be doing it to both sides, so I don't actually change my inequality sign. All I'm really doing is simplifying, and when I simplify, I can multiply. All right, so this is still -12r. -1 times +5. I know that's going to be positive or negative. -1 times 5. 5. -1 times -13. That's going to be positive. How do you know it's positive? They're both negative. They have the same sign, so I will put it plus. Okay. And we're having just multiplying by 1 really. So you could, if you have like sibling maybe in kindergarten and lower, you could probably teach them anything times 0 or anything times 1, right? Greater than or equal to 9, and all I'm doing now is combining like terms and I'm simplifying. Okay, so before I can start doing my main steps, I need to combine this -12r and the +13r. What is that going to leave you with? This r. And right here, like R, I think of like a bunch of just bad pirate jokes that deal with that. Okay, so this is really nice because it's just one R. So if it was like 2R, then we know we have to divide by 2 probably, but it's just one R. So the only thing we have to do is to add 5 to both sides. And I get R. Don't need to change the sign because I'm not even multiplying or dividing, let alone it being a negative number. Now I just have 9 plus 5. Now maybe this one you got memorized. I could also think about taking 9 plus 5 and splitting it into a 1 and then a 4. The reason why I picked 1 is because 9 plus 1 is 10. Add 4 more, then that's 14. I think I do that even for like pretty small numbers. But okay. Just some quick practice if I wanted to graph this. What's the only number I care about on this number line? 14. So maybe some of your other teachers will make you plot a bunch of other tick marks. I don't care. It's just going to make it look more cluttered. Is this going to be an open circle or a closed circle? It is a closed circle. Now to use our tip, like our hint, the variable has to be on the left, so I'm making sure it is on the left, and it is. So I can use that this inequality sign is pointing to the right to tell me, hey, let's shade to the right. Okay? So I'm going to skip D. You want help with this one? Alright, let's check it out. Maybe you're looking at this and thinking, well, fractions. Maybe you're looking at this and thinking it's math, I don't like it, period. Okay. Let's go back and say, hey, let's get rid of the fractions. What would have been the step that we've done? Let's even change this so it'll be a little bit different. Let's call this a 7 and then this a, let's change this to a, we'll just keep this one a 3. No, let's change it to 7, just because I want it, just to make it a little bit simpler, but a little bit different than the last fraction problem we had. Because the last one also had 3 as a denominator. What can I do to get rid of the fractions? Multiply. Well, how many fractions do I have? 2, but they happen to have the same denominator. Okay, so I really only need to multiply it by one number. If they had different ones, like say I would have kept this as 3, then I would multiply the left side and the right side by a 7 and a 3. And then also the right side. But I'll leave it here. I'm going to multiply the whole left side by 7. And this whole right side by 7. Now the part on the right gets a little bit confusing. So we'll do the left side real quick and then we'll slow down and talk about the right side. Okay? Over on the left, I would have like a 7 times 2/7 k plus 7 times 5. And then some of these maybe you can just do in your head, and that's totally okay. Less than, and then all I really want to do on the right is put the 7 first, put the 2/7, and then put the k plus 3. Okay, so let's do the left side. These will cancel, the 7 and the 2/7. The 7's cancel, that's why we picked the number 7, because we knew it would cancel out that fraction. All I'm left with is just 2k. 7 times 5 is what? 35. Alright, not changing the sign. Okay. Let's think about this. 2 times 3 times 4. What do we need to do here? So just kind of side example. 2 times 3 times 4. Could I just do 2 times 3? I could. It's a first start, maybe. This would just be 6, right? And then I still have the 4. And then I multiply, right? What I don't do, so then this is not good. 2 times 3 times 4. I don't say 2 times 3 is 6, and then also say 2 times 4 is 8. Right? We know not to do that. You just do like 2 things together at a time, and it becomes maybe something new, and then that's it. Right? If I did do that, 6 times 8 is 48. My answer is going to be different. Okay? It's different by twice because I multiplied by 2 one too many times. So if I'm looking over here, back to the one on the right, I can just take care of these first And then I'm not going to say, like, whatever this becomes, I'm not going to say, and then I'm also going to multiply 7 to those others. Okay, so what is 7 times 2 sevens? Starts with a D in Spanish. 2, sure. Alright, and then I get k plus 3. Okay, I don't need to multiply the k plus 3 by 7 as well. It's just like when we were talking about the examples up above on the left. Like, I wouldn't say multiply 2 times 3 and 2 times 4. It doesn't say that. Okay? Now I still need to maybe distribute a little bit, right? On the right, so I still get a 2k plus 35 is less than, just to save some room, I'm just going to multiply them together. 2 times k is 2k, and then 2 times 3k is 8. Okay? So you can always just go straight in and work with the fractions, but I know sometimes a lot of us would rather not work with fractions, so maybe give us an extra step or two, but it cleans it up in the middle at least. I maybe want to move the k's over to the left, so I subtract 2k from each side, the ones on the right cancel, and then I have just the 6 on the right. What happens to the k's on the left? They also cancel. Okay, so we did talk about something like this either last week or the week before. Okay, what do I do at this point when my k's cancel out? It's no solution. How do you know? Not necessarily, because if you have no variables, it's going to be either no solution or infinitely many solutions. So it could be like 0 or like there's like so many we can't even count it. How do you know that it's one or the other? We have to think about like chapter 1 when we got something equal to something with no variables. Well, is 35 less than 6? No. Okay, so I would say maybe even that's false. If you get a false statement, then it just means there is no solution. So it is no solution, but not because the variables cancel out. It's a no solution because it's just false. Yeah. It's false, and then this would be a no solution. Okay, so remember on the first test there were some questions like decide if it's one solution, infinitely many solutions, or nope, I'm not sure what I said, but there were the 3. Okay. What if it would have been switched around? What if it said 35 is greater than 6? That would have been true, and then that would be infinitely many solutions, or infinitely many, and I would know what you mean. Okay? Alright, so we've done some of like the toughest ones, maybe the distributed and the fractions. E isn't too bad. I just have a little bit more, I have to do a little bit of combining like terms. So on the right, I need to combine my 7x and my negative 4x. Alright, on the left, it's just 3x plus 6 greater than, what is 7x and negative 4x combined? Yeah, 3x. Alright, so then I know like this is maybe really easy to think about, but just to apply to make it tougher problem, I have a positive 7 and a negative 4x. I would subtract those two numbers. 7 just goes on the top because it's bigger. Subtract. I get 3. Then I decide, do I keep it positive or do I change it negative? And in this case, I kept it positive because the 7 is positive and it's the bigger number. Alright, so even though that's something I can do in my head easily, I can still apply the logic. So if I'm doing like double-digit numbers, I can do the same thing. Okay. What's next? Well, combined like terms normally means on one side or the other. But when you mean combined like terms, in a sense, yeah, I want to move maybe all my x's to one side and then everything else to the other. Okay. So maybe I subtract 3x. Okay, 3x minus 3x is 0x, or just nothing. I have a negative 6. Also, again, my 3x's, my x's on the left, they also cancel out. So we run into a similar situation that we had for the very last problem that we did. Okay, what's the difference here? It's true, which means
One solution.
there's one solution, there's two solutions, there's infinite many solutions, okay? Because what it means is if you get your variables to cancel out, and a true statement, what it says is like, it doesn't matter what number you plug in x, it will always work, okay? So this one's true. Therefore, there is an infinite, and I'll put infinitely many solutions. Okay, so maybe highlight these, and maybe highlight the fraction ones because these are some of the tougher ones. But definitely you want to think about like we ran into where the variables canceled out, and we have to decide whether it's infinite or no solution. Let's do F real quick. So yeah, there's only like 7 problems on this test, guys. But I mean, part 3 is 6 parts. Okay. The actual test will only be front and back. Okay. Okay. For F, I will go through this one a little quick. Okay. I've got 8x plus 3 greater than or equal to 5, and then the first thing I had to do was multiply that negative 4 and then 2x. So I'm just going to get a negative 8x. Okay. You really got to be careful here because what I see sometimes students do with this is they turn this into a no solution or infinite many solutions on accident. Okay? They see a positive 8 on one side and they see a negative 8 on the other side. So in their head they're thinking, oh, they're going to cancel each other out. But remember, the way we have to get rid of the negative 8x on the right side is by adding it, not subtracting it. So when I add 8x to both sides, I'm not going to get 0x on the left. I'm actually going to get a 16x. Okay, so be very careful about something like that. I still have the plus 3 greater than or equal to 5. I would subtract 3. I guess I'll show this that. I will subtract 3 from each side and get 16x is greater than or equal to 2. Alright. Here's another place that students will make a mistake. What do you have to divide both sides by? 16. What would you rather divide both sides by? You'd rather divide it by 2, so these students are either thinking, oh, I actually have to do it the other way, or I want to do it the other way, but no, it is still divide both sides by 16 because we're trying to get the x alone. I'm dividing, do I need to flip the sign? No, it's only dividing by a negative or multiplying by a negative. So I keep the sign the same. So I do get 2 over 16. That's fine. You can get fractions in real life. You can get decimals. But we have like coins instead of just dollars. 2 over 16, how can I reduce that? 1/8, yeah. They are both divisible by. So I would be looking for you for full credit to go that one extra step and simplify your function. I don't think we couldn't graph the last two, but I could graph this one. Only number I care about is 1/8 would be a closed circle, and then I shade to the right. So cool. So it doesn't ask you about these, but just to give you lots of practice because you do have a few where you do need to graph it. So I want to give you plenty of time to practice this. All right. We got a bunch of similar problems. Hopefully I didn't copy. Sometimes I accidentally copy the same problem. Yeah. Okay. Let's check number 4. Number 4 is almost like number 3 because you have to graph it, which we've already been doing anyways. Okay. What do I have to do for the 4th thing? Subtract 3. 1. Even though there's a bunch of tick marks on here, if you really want to, you can fill it in, but I would put 1 somewhere in the middle. Put a circle there. Close it. I'm sorry, do not close it. And shade to the left, or do we shade to the right? To the right. Cool. And B, just slightly tougher because there's a few extra steps, but there's no fractions or anything that's like that much extra there. Zoom in on that. What do I have to do here? Add 4z. Is that what you mean? Yeah, we could add 4z. Alright. The ones on the left, they will cancel. I have just a 5 left over. 5 is greater than or equal to just z. Okay. If I'm graphing this, what's the one number I care about? 5. Put it there. And it will be a closed circle. Okay? Now remember when we shade either to the left or to the right, we can use like the arrow, or think of like the sign as like an arrow almost, or like the tip of an arrow. What do we have to be careful about though for using that tip? So it has to be true. More detailed though, I should say. The variable actually has to be on the left. So right now, if I'm looking at this, if you go too quick, you would say, oh, it's pointing to the right, so I'm going to shade to the right, but it's not because the variable's on the right side. So you either know that, oh, it's actually going to be the opposite, or I'm just going to switch this whole equation. I'm going to switch the sign so it's going that way instead. Put the z on the left and put the 5 on the right. And now my variable's on the left, and then I can shade to the left. Okay. Alright, so number 4 should be pretty quick. Yeah. Okay, and then I think we have 3 more questions after this. You guys got that? Solve the, okay, so 5, oh, it should have been C and D. Not a big deal. Okay. So some of the problems, if we're looking at number 5, they're all inequalities. So what we have going on here is compound inequalities. Okay. Those are the things where you shade, you have 2 points that you care about, and you either shade in between them, or you're going to shade on the outsides. Okay. We also have some absolute value inequalities too. Okay. So let's do the first one. If you see this or, it does not mean pick one problem or the other. It means you're going to shade one way or you're going to shade the other way. So we'll do this one real quick. I got to get the v by itself on the left one. So I would add 5 to each side. 5's cancel out. Then I have just a 7v greater than or equal to 7b. What do we do next, guys? Divide by what? 70 or 7? 7. Do I need to flip the sign? No, I do not. B is greater than or equal to 10. Okay? And we'll come back to that. You get everything initials? You have to get these initialed by your teachers.
I did.
What about?
Let's start off.
Oh, but your plan too.
Okay.
Okay. And then before we try to plot that one, let's simplify the inequality on the right. Remember, you don't pick one, you gotta do both. I would add 2 to both sides. Get a negative 3v greater than or equal to negative 2 plus 2 is actually 0. Okay. Then I divide both sides by negative 3. And get v is less than, I have to change the direction of the sign. Well, 0 divided by any number except for 0. 0. So now I have two inequalities. I want to graph both of them. Okay? Let me make a number line. This time, I have two numbers that I care about. Okay? And remember, we go smaller numbers on the left to bigger. So make sure you put the 0 on the left. Okay, and then the 10 on the right. I don't really care if you put all the numbers or tick marks in between. Okay. Okay, so then I'll do the one in green. The one in green will be a closed circle at 10. Do I shade to the left or to the right? To the right, and my variable is already on the left, so I know it's okay. Shade to the right. If I do the one in orange, it is also closed. You could have both open or like a mix. And this one shades to the left. Okay, so notice the difference. We actually, like, for this inequality, it's almost like you could use any number possible except for numbers that are between 0 and 10. Okay, if you think of like at a theme park, there's normally like the little, it's like usually like a post with like a little thing, and it says you must be this tall to ride. That's normally the only thing you have to care about. But probably if you're like 7 foot something or really close to 8 feet tall, they probably won't let you ride rides either because they don't want you to use any body parts. So if you think about it, if you go on a roller coaster, there's probably a range that's like too short. Usually that's what we care about, but also too tall because you don't want to like stick your hand up or even like your head. Good?
Yes.
Okay. All right. Let's try 5A, B. Okay. This one is not an OR inequality. You guys know the other type of inequality besides OR, like the compound? Or would you say and? Yeah. So if you think like and/or, like if you're writing about it. I want to get the J by itself. Okay. Now sometimes students get stumped on this, but if you have to, think about it as if, let's see if this is, think about it as if this wasn't there. Then you would know, like, okay, well, I would know what to do. I would subtract 5 and divide by -5. Right? You would do the same thing if the 15 was there instead. So when we're going through this, we're going to do the same thing to not both sides, to sometimes they call it all sides. Okay, I've heard some teachers in college say all sides, but you can say all 3 parts if you really want to. Same rules apply. So first thing, I would want to subtract the 5. Now, if it was only the one side, only the 15, I would subtract the 5 from there. But there's 3 sides, I'm going to subtract it from all 3. Okay. So 15 minus 5 is 10, greater than or equal to -5j, which is greater than 5. Alright, so what do you guys think we would do next? Well, what would you do if this was like not even there? Not add 5. Like if it said just a -5j is equal to 5. What would you do there? Divide both sides by -5, right? So I'm going to do the same thing here. So I'm going to get rid of some of this stuff. I'm going to divide this by -5, and then I will divide this by -5, but I also have to divide this by -5. So we're still doing inequalities. If we're dividing by a negative number, that will also change the sign. It'll change both the sign directions. So 10 divided by -5 is -2. I have to change that sign now. And then I get just the j in the middle. Change that sign, and then I get a -1. This should make more sense because if you did not change the signs, and then you were just ignoring like this right here. Right now it makes sense. It says -2 is smaller than -1, which is true. But if I had it the other way, it would not make sense. Okay, so that would be a little hint that hey, you forgot to change the signs maybe. Okay, so when you're doing a like compound inequality like this, and this is an and inequality, you want just the variable by itself in the middle. Okay. How do I graph this? Well, how many numbers do you think I care about here? 2 of them. Okay, be careful when you're graphing this because we're so used to working with positive numbers. Remember that the -2 is on the left and the -1 is on the right. Okay? And then this is going to be an open circle, and this one will be an open circle. Now the difference between and or is or you shade on the outsides, ands you shade on the inside. Okay. Now if I think about like using my tip of like pointing one way to shade, it makes sense here, but every once in a while I get students ask, well, like it makes sense the j is less than -1, I'm going to shade to the left, but then students don't, or maybe they don't like see here when I'm looking at -2 is less than j, why don't you shade to the left? Well, it's because the variable is actually on the right. So if you were to flip it, you would be shading it to the right instead. Right? And I care about the stuff that they overlap. So you could think about an inequality like this as being the people that can go on that ride, the shaded part. Or maybe you think about it as like it's the times that you can see this spot or the times you can see Mr. Tate. Like maybe this is like my times of the day where I'm at school or I don't have a class that say Tuesday or something like that. Okay, so then let's do the absolute value ones. Okay. The back page was not like the best side on the test, and it had a lot of these absolute value questions. Okay, so we'll talk about these. If I'm looking at this one here, if this was an equal sign, I would still want to get the absolute value all by itself. All right, in this case it already is. If you look at the next one, you can tell that there's going to be a little bit extra work. Okay. Now the thing about absolute value, that's always going to be an and or an or. Okay. So if you have an equality, I'm going to split this to a plus version and the negative version. Okay. Now I think when I explain it with the equal sign, like the fast way is just to make the answers. One answer the whole thing positive, the other answer the whole thing negative. But really, we could do this too. And this helps to make more sense when we're doing absolute values, or especially for inequalities. Okay, I'm going to rewrite this. Okay, so just to explain this real quick. This is like the positive version of the answer. So like when we did something like the absolute value of 10 or the absolute value of -10, it's going to give you a positive answer. This is the positive version. This is the negative version, and I denote that the negative sign is there. Okay? Why they both have the sign opening the same way, but let's simplify some of these. So on the left, I don't really need the parentheses. So let me just drop it. On the right, I can either distribute -1 to both. I can say, oh, -1 times this and -1 times that. Or I can say, well, we're dividing it by -1 and we're dividing it by -1. These would cancel each other out, and then I have a 3x minus 9. Now I get a -2, and then I have to split the sign direction because I just divided both sides by -1. Okay. So So it depends on which videos you guys are watching. I forget which ones I put up for this. Sometimes it just goes straight to the positive version of the answer and the negative version of the answer. But this is where it comes from. You have a negative version and a positive version, and then to get rid of the negative version, you divide by negative. Okay? Just going to solve both of these now. Add 9, add 9. 3x is greater than 11. Divide both sides by 3. And I get x is greater than, and I'll just leave it as 11 thirds. If I'm working on the right side, I'm also going to add 9 and add 9. Getting 3x less than 7. Divide both sides by 3. And I get x is less than 7 thirds. Okay. Now let's put this on a number line. Because I do the graphics. I'm going to kind of put it up above. What are the two numbers that I care about? Yeah, 11 thirds and 7 thirds. Which one would come first on my number line? Yeah, 7 thirds. If you are not sure, for example, if your denominators were different numbers, it might be harder to tell. Just punch in your calculator, say what's 7 divided by 3, and what's 11 divided by 3. Okay, and that will tell you for sure. Okay, so I'll do the purple one for the one on the left. 11 thirds. It's not going to be a filled in circle, it'll be an open circle. And I shade to the right. If I do the one in this like red color, this is an open circle and I shade to the left. Would this be an and or an or inequality? This would be an or. Or is opposite. It's going to be like, it could be smaller than 7 thirds, or it can be bigger than 11 thirds. Okay? The hint too, I think in one of the videos they might watch, when you read this simplified, it's this this absolute value is great, or, did they bring that up in the video or no? Or not, maybe not there. Great, or, so you know it's going to be that one. And if you do less than, it would be less than, and you really emphasize the and part into an and. And I think that it will. Okay, let's do this one. And then I think there's 2 after that, which don't take too long. Now, what would I do here first? And I noticed that a lot of you guys are doing something different, which technically will give you the same answer, but you're just doing extra work. How would you start this? Would any of you guys distribute to 5? You could, but you're actually making your problem tougher in the long run. But you could. Ideally, we don't really want to make the absolute value bigger on the inside. So if you distribute the 5 in, you're going to get a 25 plus 15z. Okay, I kind of like it being smaller already. So really what I want to do is pretend like this was a giant x. And if I had a 5x plus 4 less than 9, then I wouldn't say, oh, I'm going to distribute the 5 to the x. I would actually just say, oh, let's subtract both sides by 4. And then divide both sides by 5. And then just get x is less than 1. Except that x would actually be an absolute value. If you multiply it, then you would actually have, you would have more stuff to do. Okay, and I think I was playing someone yesterday. It's like if you're trying to dig a big enough hole, it's like you're trying to get x by itself. If you distribute it, you're actually like digging dirt out, and then you're like kicking dirt back in when you distribute it. And then it's fine, you just have to like re-dig it back out. So it's okay, sometimes we like to do, like when we do the fraction thing and we get rid of the fractions, we're giving ourselves an extra step, but it helps us out. So if you really want to, it's okay. So in this case, I want to say subtract 4.
Usually I'm supposed to do that on Friday, so.
Okay. Then I would divide both sides by 5.
Question, what did you do? What's class?
And then I get the absolute value by itself.
I was thinking that you're making another version of the
And then at this point, it's going to be kind of similar to the problem that we just did because at that point, the absolute value was already by itself. Okay, so let me zoom back in. This was okay, I have the absolute value by itself. At this point, I'm going to split it up. Got the positive version, the negative version. I've got a positive 5 plus 3z less than 1. If you want to help, if it helps you think about, remember, this is like the positive version. And then the 5 plus 3z. That's the negative version. This will be 5 plus 3z less than 1. If I get rid of the parentheses, you might not even write it to start with, which is okay. This is going to be 5 plus 3z. It's just going to make this a negative 1 and then flip the sign. So, what's it doing? I have to remember that you get more than one actual test. You guys are probably running out of room. Okay, so we'll solve some of these. Subtract 5.
I looked at it, looked at the question, and I was about to.
Subtract 5.
You know what? I'm just
Then you get 3. Z is less than negative 4.
Students, if you have not made your lunch choices, please come up now. Thank you.
And then divide both sides by 3. Z is less than negative 1. 3. I'll do the one on the right really quickly too.
I had a feeling
Subtract 5, subtract 5. 3z is greater than negative 6. Divide both sides by 3 and you get z is greater than negative 2. Alright, so we can grab
Yeah, she would.
Alright, what are the two numbers you care about? Negative, yeah, so negative 4/3 and negative 2. Which one's bigger? Well, normally if it was just 2 and just 4/3, 2 would be the bigger number, right? Because 4/3, if you guys were to calculate that onto your calculator, that would be like 1.3. Or if you want to make it as like a mixed number, it would be like 1 and 1/3. Either way, it's a little bit easier to tell, like compare it to 2. Okay, but since it's negative, it's going to be opposite.
So there's going to be a video.
So the negative 2 is actually smaller and the negative 4/3. If you want to even just put negative 1.3 repeating, that's okay. Okay, let's check out the one on the left. Z is less than negative 4/3. That is going to be an open circle. And I will shade to the left. Okay? I'm going to leave it like that for now. And then Z is greater than negative 2. That is an open circle, and I will shade to the right. So my actual answer will be the parts that would overlap each other. Okay, so notice that if I was to shade it this way, it would go that way. If I did the red one, it would go. It would go this way. What you really want is the part that works for both of them. So I will do that in open circle, and everything in between. Okay, that's my actual answer. Okay. Here's your sheet. what was the tip like on this? If you're looking at the absolute value of 5 plus 3z is less than, this is going to be an and type of number. Alright, plus 2. Okay, so 6 and 7. It's a word problem. Okay, so you will get 2 kind of word problems, but they're not going to be. Like the hardest part is just setting it up, and then the solving part is going to be as easy as some of these you did already. Okay. So for number 6, it tells you need to fold at least 100 napkins for the restaurant you work at. So I used to work at Olive Garden, and I worked at Cheesecake Factory as well. Actually, I worked at BJ's, but I didn't. But a lot of times, normally the busters have to fold it napkins. But if like the busters were short, then they would make you fold it out completely, which is dumb. So you'd have to like sometimes they would say fold 25 napkins, sometimes they would say fold 50, one time they said fold 100, so that kind of stinks because you're just ready to book it at the end of your shift. Do any of you guys work or no? Okay, so when you do and you're ready to go, you don't really want to help somebody else do their job, you just like want to leave. Okay, so but you're working in a restaurant, they could ask you to fold napkins, okay? But in this case, so you need to fold at least 100 napkins for the restaurant you work at. If they told me to fold 100 and I folded like 120, they would not complain. They wouldn't say anything. But if I folded 99, then they would say that's not enough. Okay? You folded 34 so far. All right? Write in inequality that represents the number of napkins you have left to fold. So I need to figure out 3 parts, kind of like the very beginning of this review, when we had something similar to like the 1A, B, and C. We have to do something similar, except we actually have to solve it. You need at least, so that's kind of important. You need at least, and then 100 napkins. You have 34 so far. And then I need to use a variable, and they're telling us we're going to use n, and then n represents, not that you don't need to write this, but because it's already written there, but just to emphasize, the n represents the number of napkins you still need to fold. Are any of you guys thinking about getting a job soon? Yeah? You have a job in mind, or just kind of wherever we'll hire you?
I applied to Marshall's.
Oh, okay. When are they going to open that?
No, they said to submit applications and then they'll go.
How did you guys? Not really in your mind right now? See, I started working at Algebra, so I had to take for my car and everything. If you're someone like Miss Cook, her parents bought her car for her and everything, so just different situations. So n is the number of napkins you still need to fold. Okay, so you have folded 34, and then the n would represent the number left you have to fold. Okay, so we're not going to just completely ignore the 34. You're going to add them to how many more you fold. Okay. You need to get to 100. It does not need to be exactly 100. If it wasn't exact, then we would maybe use an equal sign instead. Okay. Which inequality sign will I use? Which one has to be bigger, the stuff on the left, or will 100 be the bigger number? Yeah, the stuff on the left, because the stuff on the left is how many you actually fold. It could be bigger because, like we said, if you did 101 napkins, they're not going to get mad at you. All right, so the stuff on the left has to be bigger. Can it be exactly 100? Would that be okay? Yeah, so then I have the or equal to part. Okay? Now that's the first part of the problem, and it's probably the toughest part. The last part you need to do is just actually figure out how many napkins at least you need to fold. So then we would just go in. In this case, all we have to do is subtract 34 from both sides. Those cancel on the left, and you have an n greater than or equal to 66. So the minimum you would need to fold is 66 napkins. Okay. Sometimes if you're waiting on somebody, you'll fold napkins after they're done to help them, so you guys can both eat together at the same time. Okay, that's it. Alright, so let's try something different. So the scenarios may be slightly different on the actual test, but we're doing something similar, okay? I don't think it's a napkin problem, but it's, yeah, we just have to break it up into the parts. Maybe the key thing you gotta look for is the at least, alright? And then identify the other two parts. For us, it was the 100 napkins, and then the 34 napkins so far, okay? Let's check out 7. Greg has $500 in a savings account at the beginning of summer. I should have put a comma there. He wants to have at least $200 at the end of summer. Okay, he withdraws $25 per week for food, clothing, and movie tickets, I guess. How many weeks can Greg withdraw from his accounts? So basically what the problem's saying is he has a certain amount of money. He's spending like a certain amount every week, but he wants to make sure that he doesn't go too low. So if he spends like $100 every week, he wants to know how many weeks could he spend $100 and still have enough left over. So in this case, he wants 200. Okay. What are the two easy parts? This was a little bit tougher. What are some of the parts do you think that are important? You think the fact that he's spending his money on food, clothing, and movie tickets? No. Not really. I could have changed movie tickets to CDs. Something important is the 500. Okay, this is what he has in the beginning of the summer. Okay, so we know that this is like the most that he would have. Something important is he wants to have 200, and he wants to have at least 200. Now this part has one extra little wrinkle, because it says he is spending $25 per week. Right, and then above we know that we're using W to represent the number of weeks. He's actually spending that. Well, we write that. W equals the number of weeks. He's spending money or taking money, however you want to write that. And this one, I'll even go specific. Number of weeks he's spending $25. You may have to get that specific. Okay. Any ideas? Any ideas for like maybe the 3 parts? Do you think one of the 3 parts you would know? What's kind of like the 100 in the last 100? What's kind of the 100 part? It's 200, right? Because for the napkin problem, he needed to get to 100. This problem, he's going down to 200. So over on the right, I will put 200. Okay. Now I could also think about the sign that I want to put. Can it be smaller than 200? It cannot be smaller than. So I actually know that whatever he spent, it needs to be greater than. Or it could be exactly 200. Alright, so maybe the toughest part is figuring out the left side. Do you have any ideas? How much does he start with? He starts with 500. Okay. Will his money go up at any point?
No.
No, it actually goes down. How would I probably represent going down? Subtraction. Okay. And it's going down by 25, but it doesn't only go down 25. It goes down 25 every week that he's actually spending. So then we put the W. Now that's the first part. The second part is then figuring out the number of weeks. So let's move in on that. Okay, it's up to you. Sometimes I know people like to make the W's positive, or we would want to make positive. So we could just subtract 500 from both sides and get negative 25W is greater than or equal to, what is 200 minus 500? Negative 300. And then, so just to practice that point again, different signs, you have a positive 200, a negative 500, so I will subtract. And then this one's a little easier to tell, it's going to be 300, but the 500 was bigger and that was negative, so it's a negative 300. I then divide both sides by negative 25. What's the important part to remember this? Well, it will be positive. You have to flip the sign. If you don't flip the sign, then you're going to say that you can actually spend more money than you really wanted to. And then we want to figure out 300 divided by 25. And it will be positive. Think that in your head or? Yeah. So, I mean, you can always punch this in your calculator. I would be thinking, okay, I know 25 goes into 100 4 times, and then I would multiply that by 3. So, he can pull out money for at least 12 weeks, but if he goes another week of pulling out that money, then he's going to have less than $200. Okay? I think that's it. Any quick questions on any of the problems we did, or you want to like see an extra problem like it, I should say. Okay, so come back. Just having these problems done is not going to get you very many points out of 30, so you have to get them all. Okay, stop this here.